Hello everyone. In this video we'll be studying differentiation rules. We will be focusing on the chain rule. We will understand the chain rule deeply and learn how to apply it correctly with some functions. And after that we will learn some tips on how to apply the chain rule very quickly. This topic is under the IB Mathematics Analysis and Approaches Standard Level and High Level. Here we have a table for the derivative rules of some functions. This table is available in the formula booklet in the IB exam. Here we have two functions to differentiate. The first one is simple and it doesn't need the chain rule, but the second one does need the chain rule. So we'll differentiate both and understand the difference between them. So here, to differentiate the first function sine x, as you see, it's cosine x. We'll follow this rule here. So the derivative will be simply cosine x and that's it. We don't need the chain rule. But in the second example, as you see, it's not as simple as the first one. Here, the inside or the inner function is just x. But here we have 3x squared plus 8. So it's like we have an inner function here inside another function. Let's call this sine, the outer function. So generally, when we don't have only x inside like this, then we use the chain rule and we consider this to be the inner function. So what is the chain rule? As you see here, it's given in the formula booklet. So the derivative dy over dx can be expressed like this. dy over du, then multiplied by du over dx. As you see here, we multiplied top and bottom by du so that we don't change this fraction. See now here, if you cancel them, you still have dy over dx. But now, what is u and how do you apply this rule? We will understand from this example. To apply the chain rule correctly, you assume the inner function, the inside function or the brackets to be u. So here, u is 3x squared plus 8. After that, we will rewrite the function like this. It will become here sine of u. So we have here sine u. So as you see, when we use the u substitution correctly, the function will always be simplified to a simpler version where the derivative of this function is available in this formula booklet. Now, we will differentiate this according to the chain rule. So dy over dx equals now, as you see first, we have dy over du, which is the derivative of the function y with respect to the variable u. So we'll differentiate this with respect to the variable u as if u is the variable instead of x. And as we see here, the derivative of sine becomes cosine. So when we differentiate this, it becomes cosine u. Then times now, here we have a very important fraction. du over dx always represents the derivative of the inner function u with respect to x. So this is the idea of the chain rule. After we differentiate the outer function, then we multiply by the derivative of the inner function u with respect to x. Here, if we differentiate this inner function with respect to x, we will have only 6x as we learned in the previous video. Here we can rewrite it like this. 6x multiplied by cosine u. At the end, we have to replace u back in terms of x. So we have cosine and u here, as we know, it's 3x squared plus 8. So this is the derivative of this function using the chain rule. But here now, in this method, I used the chain rule formally and fully as it's given in the formula booklet using the fractions and these steps. But as an IB student, from now on, you wouldn't be following all of these steps and this long rule. We can do it faster from now on. But I did it in this way first to understand the chain rule very well from the beginning. So to apply the chain rule quickly from now on, we will say, so we will differentiate this again quickly. the derivative y prime will be, first, we differentiate the outer function as it is without changing the inner function. And when we differentiate sine, it becomes cosine of the same inside, 3x squared plus 8. Then here we multiply by the derivative of the inner function only. So the derivative of this, which is 6x, which is now simply again 6x multiplied by cosine 3x squared plus 8 as we got here. Let's now move on to these examples. Here, the first one is simple and it doesn't need the chain rule, so we can differentiate it based on this rule. First, we'll put the 5 down and multiply it by 3, which is 15, and we'll decrease the power of 5 by 1, which is 4. So this is the derivative. And if you would like to know more about how to differentiate powers of x, you can check the video that appears top right on the basics of differentiation. See now here the difference in this example. Here under 5 we have only x, but here we have an inner function 7x plus 2. So here we need to apply the chain rule quickly. So as we said first, in the quick way, we differentiate the outer function. We put the 5 down and multiply it by 3, which is 15. Then 7x plus 2, we decrease the power of 5 by 1, which is 4. But as we studied in the chain rule after that, we multiply by the derivative of the inner function, which is here, this, what's under the power. And the derivative of 7x plus 2 is only 7. So here we multiply 15 by 7, which is 105, multiplied by 7x plus 2 to the power of 4. So this is the derivative. Now we will move on to the derivative of the cosine function. So here, to differentiate it quickly using the chain rule, the derivative will be, first, we will keep the 4 that's multiplied by cosine as it is. But then, we will differentiate the outer function, which is cosine. As we see here, when we differentiate cosine, it becomes negative sine. So I will write the negative first here. Then cosine will be sine when we differentiate. So 9x minus 5. We don't change the inside now. Times. According to the chain rule, then we differentiate the inner function, which is the inside here, 9x minus 5. The derivative of that would be only 9. So negative 4 times 9 will be negative 36 sine 9x minus 5. So this is the answer. Let's now move on to differentiating natural logarithms. Here, to differentiate quickly, first we see when we differentiate ln x, x only inside, then it will be 1 over x. But here we don't have x only inside, so we'll apply the chain rule. So the derivative will be, also we have 1 over. Here we have x and x, so here it will be 1 over the inside, 5x minus 8. But after that, as always, we multiply by the derivative of the inner function. The derivative here of 5x minus 8 would be only 5. So now we can multiply 5 by 1, so we have 5 divided by 5x minus 8. So here is the quick way to differentiate natural logarithms. First, we differentiate the inner function, which is 5, and then we divide by the same inner function as it is down. This is how we can do it quickly. Another example here, we have ln of sine x. So to differentiate this, first we will differentiate the inner function sine x, which becomes cosine. Then we divide by the same inner function sine x. And if you are studying IB Mathematics high level, you would know that cosine x divided by sine x would be cotangent x. So the derivative of ln sine x is cotan x. Now we will move on to differentiating exponential functions with base a. So here the derivative f prime will be, First, as you see, when we differentiate e to the power of x, it remains as it is e to the power of x. So when we differentiate this, it remains as it is e to the power of 3x power of 4 minus 7x plus 2. But after that, we differentiate the inner function. Here, the inner function would be the whole power is the inner function u. Because if we were to apply the chain rule formally using the fractions, we will assume this to be u, and then the function will be e to the power of u. So here, this is the inner function. When we differentiate u, it becomes 3x power of 4. When differentiated, will be 12x cubed. 7x will be just 7, and when we differentiate 2, it goes away. So this is the answer. We can write it like this first. 12x cubed minus 7 times the same e. 3x power of 4 minus 7x plus 2. So here is the quick way. To differentiate e to any power, first we differentiate the power and then we multiply by the same exponential function. Another example here. If we have y equals e to the power of 7x cubed, to differentiate it quickly, y prime will be, first we differentiate the power 7x cubed, which becomes 21x power of 2. Then we multiply by the same exact e, 7x cubed. Now we will move on to differentiating these examples. As you see here, we have two functions that look similar, but they are completely different. Here we have sine of x power of 4, so the power of 4 is on x only, but the sine has a power of 1. And here we have sine power of 4 of x. So here the power of 4 is only for the sine. So here, when we differentiate, we will have the first one, the derivative will be. First, it would be easier to visualize it like this. We can put brackets here, so it will be sine of x to the power of 4. First, we differentiate the outer function sine, which becomes cosine, and the same inside x power of 4. But then we differentiate the inner function x power of 4, which is 4x cubed. But now, in the second example here, we have sine power of 4x. It's easier to visualize it like this. Here we have sine x, and all raised to the power of 4. So here the inner function is fully sine x, not only x. So to differentiate this, first we put the 4 down and multiply it by sine as it is. Then we decrease the power by 1, it will be 3. And after that, we differentiate the inner function sine x, which is cosine x. Or you can rewrite the derivative like this, 4 sine cubed x times cosine x. I hope that you have found the video helpful. Please consider subscribing and hit the like button, and stay tuned for future videos about differentiation and integration.